Please welcome Boriss, who is second best database comedian. also ranked #1 air guitar player.
Yes.
And holistic software engineer.
Yes.
From EDB.
Yes.
And he's going to play data modeler today for PG Conference Chess Tournament.
Yes. Thank you very much, Mejias, for that presentation. I really like it. So, as Mejias was saying, I'm going to be talking about data modeling and PostgreSQL based on a chess tournament, which is starting from the use case and then going to good practices in data modeling instead of saying you what are the best practices, best data types, or whatever. No, the idea is to listen to whatever is in reality and then try to translate that into a technical solution. Yeah, I'm a holistic system software engineer from EDB, and I'm super happy to be in Riga because Riga is the home of the magician of Riga, Mikhail Tal, eighth world champion, and he did it for 2 years. That's one of his pictures from Wikipedia, but so this other picture is in the Riga Chess Club that lent us some chessboard so that we can play chess during the week, so we can find us in the hacker rooms if you want to join and play a little bit of chess, learn chess, and you can see how famous and appreciated he is. They put a painting of him on the chess club. Now, not only in the chess club they play, Salonik also play chess, and you have here the 3 best players from last year's tournament, and there are going to be some of them playing here today as well, tomorrow as well, and the idea is that this tournament was started as a use case for putting some information on a database, and we wanted to see how much of those guarantees can be in the database so that you can save code in your application. Yeah? So, the chess tournament of the PostgreSQL Chess Club, which is also going to be in Lichess, so you can play online with us, it was having only this very simple rule. From Wednesday to Thursday, you can play as many games as you wanted to have, so you can score as many points, and the top 4 players will play the semifinals and the final at the end. But you can play only twice against the same player. Otherwise, you want to play against me all the time so you can beat me easily and then you can score more points. No, you can play with me only twice, and only after switching the color of pieces. So if you play white against me being black, then we have to switch colors, otherwise we cannot play exactly the same game. So these 3 rules are the thing that we are going to put into a database design schema. So this is our use case. We start from a real case scenario because this was actually developed last year. And let me show you. So in the database, you have tables and rows and whatever data types you want to have. But in the application, you can have other type of things, like, for instance, JSON objects. I love JSON objects because they sound like a guitar player, like Jason. You see? Here we have 2 names of, that's actually at a certain point the youngest ever grandmaster, not women grandmaster, but really for real grandmaster, Judith Polgar, and actually Ilse Berzina, who was playing yesterday in the Riga Chess Club. She's a women grandmaster. She's from here, from Riga. So they have very nice female players here. Okay. So in the games, you will have a white player playing against a black, and then the result Judith won in this case, so you have who won the game. Very simple. Let's try to put this into tables and columns and rows and whatever. So first of all, you need to have your table, which we are going to put into a schema. We are not going to just put it in the public schema because that is not going to be something that is explanatory for you. Also, the public part is kind of the default, so you better create your own schema always for your application. In this case, the schema is called chess, and the table is called players. So even read like nicely like chess players. You see? It's good. If you just say players, it could be like any type of games, but in this case, it's a lot more descriptive. So when you have your naming, it's very good to have something descriptive. Yeah? There are 2 things that are very hard in computer science: naming things, and I don't remember the other 2, but anyway. So, look, you have a name and an email as you have in the application, yes? But we also have an identifier, which is an integer, and we are going to put this as a primary key. I'm going to explain there why this is a good practice, but the idea is that players have to be unique. So you have to have some primary key somewhere. Either you put the name as a primary key, or in this case, what we call is a surrogate key, which is just an integer. But we want that name to be unique. So this is the first thing that we are going to explain in terms of coding. Yes, this is the design. So let's go to the code. The code says, create schema chess. By the way, the slides are going to be available afterwards. You can copy-paste them into Postgres 18, which are tested, and all the code works. So if you find any typo, it's because some glitch in the matrix. Yeah? But originally, this should be all copy-paste so that you can work. Create table chess players. You have the ID, which is an integer, and is the primary key. And you have your name, which is text, and an email, which is text. There is no data type, as far as I know, for email, but you can create domains that have specific regular expressions so that you know that the format of your email is correct one. But we're not going to talk about that one in particular. We want to see the relationship between the entities, because the system is larger than the part, so the connection between the entities in this case is going to be fundamental. All right, so we have the fact that we want to have the chess player's name not being null, yeah? Because everybody needs to have an identity in this life, and if you go through your life without a name, it's going to be a very sad life. So we are going to say that this cannot be null, and then we are going to also say that it has to be unique, yeah? If you have two people that has exactly the same name, you will need to find some other ways to identify them by some other column, like register number or whatever. But then in this case, we are just going to simplify, and we are going to avoid any collision with names. All right, so the table was like this with some altered table, and then at the end, if you look at the definition of the table, it's going to be exactly like this. Name, text, not null, unique. All right, so let's do some tests. Let's insert these two players that we had. We first insert Judith Polgar with her email address. That works. Then we insert Ilse Bersina, and that works as well. So we have, you see the output. It doesn't work this, but there you go. Now we're going to try to add again Judith Polgar. Note that I can add it without an email address because I didn't put anything, regardless of the fact that you need to have an email address. You can be in your life without an email address. Maybe not without a name, but not with an email address. So this one is a valid, actually, insert, despite the fact that we have exactly the same name. So when we try to do that, then there's going to be an error coming from the database saying duplicate key violates unique constraint player's name key. And then you see name Judith Polgar already exists. That means that as a software developer, you don't need to do any test on your application. You don't need to retrieve the entire table of names, check whether the name that you are inserting already exists or not. You just try it out, and if it errors out, you say like, oh, sorry, you are violating a constraint. You need to put a new name. Otherwise, you are loading a lot of data in your database unless you have a cache or something, but then you let the database do the integrity of your data. So you put that into the design of your database, and you save a lot of code lines. There was a presentation this morning that says every 100 lines there is a bug. So if you can reduce some lines in your application, you have less bugs. So put a lot of stuff in your database. So a constraint is actually a guarantee. When you say, oh, I have a lot of constraints in my life, it sounds very negative, but it's actually a guarantee that you are not going to have these problems. So we cannot change the name, and we are not going to do a patch for changing the stuff, but think about a guarantee when you want to think about constraints. All right. Now, there is another problem here. What if somebody wants to play with the data and insert Judith Polgar, but in lowercase? Haha. This one is going to work. So this is going to be a problem for us. If I tested it, and it works. So I can insert the same name, but in lowercase. That's not good, because we want to have data integrity. So what we are going to do is, first of all, we start from here. We drop the constraint that we first put, that guarantee that you have to be unique. And then we are going to create a unique index based on a function. And that function, what it's going to do is it's going to take all the names, put them into lowercase, and then it's going to compare them. So no problem with camel cases or whatever. This is going to add more guarantees by creating this unique constraint. So now I try it again, and now it fails. You see that the error message is a little bit different. It says lower name is equal to Judith Polgar already exists. Yep. All right, good. If you have any questions, don't ask, because you need to wait until the end of the presentation. Let's remember where we started here. We say, everyone can play as many games they want, only twice against the same player, and only after switching the pieces of the color of the pieces. So let's see. We have games now. In the games, we have, again, a surrogate key. Then we are going to have a timestamp because the game happened at a certain moment in time. We are going to have the player that is white and the player that is black, which is an integer. That integer actually is going to refer to the primary key that is on the chess player. Yeah? And then we are going to have a result. I still don't know whether it should be a text or an integer because it could be any of the two. This is a choice. We are going to go for text, and we are going to put the foreign key to refer to the players in the white and the black players. Okay? Simple table, but it already established some relationship, and it's also going to help us to build this application. Here you have the code. Instead of having the ID as an integer, I'm going to put it as a serial because it's a mystery. It kind of puts you in the darkness. And then you say, oh, and now I understand, you see the light again. I don't know why it's happening, but the serial there, it means that I don't have to add it myself. The system is going to add it for me, picking up the next number that is available. Some people believe that they say, no, I don't want to have it like that. I really want to have always generated as an identity. That is also a possibility that you have in Postgres. You can read the differences of the things that you have there for one of the two. But some people, like me, prefer to have serial because I also, from time to time, I want to add my own numbers. Anyway, so there you have the foreign key. It's just the keyword references, chess players, and the ID of the player. Yeah? If it would have been here the name, I would have to put the name every time, and that will be duplicating the name of the players all the time, like you did Polgar here, here, and there, Ilse Bersina here, here, and there, Mikhail Tal here, here, and there, whereas now I just use a number that represents them, and if at a certain moment I realize that I made a typo, and I didn't write Mikhail Tal in the correct way, then I would have to change it everywhere, whereas here, I just change it in the table of players. Yeah? We're going to get back to that one. And the result, I decided to put it on text. Okay. Now, Mikhail Tal was known for being a very bold and adventurous player, and he was daring to do things that nobody else did before, despite the fact that he was as creative. He never get kind of like a Tal's variation or whatever. No, he was just creative with whatever was available. So I think that enums are available, and I was decided to be bold and use it, and that's why it is in bold font, and it's with orange color, because orange is bold. And it reminds me about the PG Day Lowlands, the second best Postgres conference in Europe. So we are going to have an enum type. So I'm going to create my own type for the result, which can be either white ones, black ones, or it's a draw, or the game is still in this is when you say Postgres so many times, it's super difficult to say progress. Isn't it? It's like in progress. Okay, there you go. Then, that one, because it's a new data type that I created, I can just put it there in a result, and I say the result is of type score. Like that, I guarantee that nobody can put like unidentified value, or they're still playing, because that will be a valid text. No, no, it has to be in progress, right? If you don't like the orange, you can also put this in blue, which is more readable. So follow me for more advices on colors for your slides. So, score. I think this is a very useful stuff, because if you put anything that is not this, it's going to fail. It works like a constraint, basically. And it doesn't have to have another table with the definition of a key for white, key for black, and then do a foreign key that references that. No, just use an enum type. It's cool. Who uses enum type here regular basis? Okay, a few people. So the other people now have discovered maybe something that could be useful for you. Okay, how you do it? You create a type called score as enum, and then you put your results there. And then instead of having the table with the result as being text, I put the results being a score, and now I have a guarantee that this is going to be always this type of scores, not anything different than that. All right, score, there you go. Now, let's remember the other two rules. Only twice against the same player and only by switching color. That means that I'm going to add a new guarantee here by saying that in the chess games, it has to be a unique combination of white and black. I cannot repeat this. I cannot have twice the same game between white playing against black. And that's enough. That's good. It's super easy. I mean, it's shown in 2 lines of code because the slide is kind of like large enough so that everybody can read it, but I could put this in 1 line of code. So I could put like 99 more constraints, and only one is going to have a bug, according to some statistics. So good. Very nice. Yeah, that saves you a lot of code. So look, I'm going to insert a game between, that happens today, basically, between Judith Polgar and Ilse, and it ended up in a draw while Judith was playing white and Ilse was playing black. And then Judith says like, oh no, I didn't like to draw with this player who has a slower elo than me, so maybe we should play again. So you try to play again, and now white wins, but then you get a duplicate key error. You cannot play again with the same colors because we just added this unique constraint saying that you cannot play twice with the same order. So you see, white-black combination 1-2 already exists. You will say like, yeah, that was obvious, you already explained this. So it's nice because it means that you are kind of getting the concept that is behind this stuff, and you, in the beginning you can say like, what is he talking about? But then it flows naturally. It means that we are all getting more understanding about how to design databases. So they can switch colors, and now we're going to play 2 versus 1, and black won, so Judith Polgar got her revenge and her point, and that works. Good. A lot of code that is being saved from the application, you can put it here so that the focus of the application development could be on the front end that has nice looking graphics, and everybody say like, wow, that's such a beautiful application. This is not very beautiful, it's just text. You need to kind of abstract the idea and think about the relationship between the data types and the guarantees and the constraints, and then you say like, wow, what a beautiful design. But it takes some time because you need to abstract this. Whereas if you focus your front end for the application, then it's immediately visible for you. Right. So by having 2 tables and a few guarantees, we already apply a few data modeling design principles. Oh, I didn't check the, is it the right spelling for principles? Yes, thank you. I always mess it up. So here I have my table, chess players, chess games, and enum type. We prevent data duplication? Yes. Because even if the score would have been text, I will have to write multiple times, write black, black, black. But in the implementation itself, it references to the index that you have in the score. So in terms of storage, this is super minimal. It's super small and enum type, which is good. I never repeat the name of the player because I have integers everywhere. So we prevented data duplication, which is one of the principles of data design. Each entity must be unique. We already show how to guarantee that. We even guarantee that some of the games combinations are unique. Now, remember, a constraint is not a restriction, it's a guarantee. And then we don't use business keys as primary keys because representations of name can change, spelling can change. We realize that there are some bugs there. So there are a lot of good reasons to use a surrogate key or not. There are articles that you can read, and then if you don't trust me, go and read those articles. Good. Now, so if you don't like the word business, because some people kind of itch the skin when they talk about business, you can just talk about we don't use natural keys. Yeah, it sounds more like organic. So what about semifinals? If I play with somebody, me being black pieces and the other one being white, and then we get to the semifinals and we play again, that would be a problem because we're not allowed to play again. So this is a problem in our design. This is coming from the real situation that we have, like how we are going to represent semifinals. Well, the same thing happened with the finals, because players are going to play again in the next phase. So we realized that we played last year and we want to play this year, so you also need to have different tournaments. So let's add more information to our restriction or to our guarantee, and then we are going to be able to put this multiple times. So let's start immediately by the tournament. We have a chess tournament, also with a surrogate key. A name of the tournament, for instance, this year is going to call Riga's tournament, for obvious reasons, with a start and an end date, and then we have 3 winners, a champion, a second, and a third, and those are all foreign keys, so we are not repeating the name, so we are respecting all the principles that we already defined. Now, we add some extra columns to the chess games, so we have now the tournament. I just put turn, but it's tournament because this is kind of like when you're drawing, and then you're getting your designs, and then you put it into code. And then the phase of the tournament, first phase, semifinals, and finals, okay? So that means that we can add now more columns to our constraint. And then you have, again, the chess players, and then you see all the arrows, how they are referred with the foreign keys. So a chess player can play many games, and a tournament have also many games as well. So this one is kind of in between to one-to-many from the 2 sizes. Remember that the score is our own data type, that can have black, white, draw in progress. And then we also have here this new unique constraint that you can play a combination of white and black in a certain tournament in a certain phase. And that means that you can have multiple phases and then you can play again exactly the same configuration. And then with that, we solve the problem that we identify in our original design model. So this is evolving your design. You don't have to have your final design perfect from the beginning because perfection is overrated. So you can evolutively get to a better solution every time with incremental changes. So this is your table with tournaments directly from the drawing. And then I'm going to alter the table chess game. I'm going to add the tournament once I created the table. So it's a foreign key. And I'm going to add the phase there. I'm going to put text here because it could be called any different ways. And I'm going to remove that first limit games constraint. I'm going to add now a constraint for limit games per phase and per tournament are in these 4 columns. And this is going to guarantee the whole thing, which is good because all the code of the application to get these rules are in the database, which I think is cool. So what about stalemate? Because some people say like a draw is not just a draw, it could be a stalemate. This is when you are not attacking the king, but the king cannot move anyway, so it's not a check, but the game is blocked. So well, you alter your data type score and you add a value stalemate, and then it's done. So you can add more things to your enum type. It's very powerful and dynamic thing. I really like it. And if you can see, if you use \DT capital case with plus, you can see all the values that are in your data type, so you can always observe what is going on. Good. So let's get back to Mikhail Tal. Why is Mikhail Tal so famous for his creativity? I have here a chessboard with this initial position. Even if you don't know chess, let me explain you this beautiful creative way of playing. He's having only 1 pawn. He's playing white. The other one has 2 pawns. You can see both of them have the queen. Both of them have a rook. We have the same value, and the knight has the same value as the bishop. So instead of just trying to exchange pieces, he sacrifices the rook by doing a check there. He loses the rook. He then menaces with the king in a position where you're going to put the queen in front of the king, so he's going to do a checkmate. But then the other player defends that position, and instead of doing something normal, he sacrifices the queen. Amazing. He first sacrificed the rook, then sacrificed the queen. So he's in a completely disadvantage with only 1 knight, but you can see how beautiful the knight can now go and take the bishop, take the rook, and take the queen. Look at that. Check. You can only move the king. Check. You can only move the king. That's why Mikhail Tal is so beautifully appreciated by his creativity. And if you want to reproduce that here, you have the board, if you want. Okay, closing words. So we did an exercise of data modeling to implement a chess tournament, but actually this could be an exercise for implementing any application or nearly any application, because we don't want to say like completely global. No, nearly any application. That means that we use a starting point with a use case. We don't start from principles and stuff like that. We really have a real case scenario from real life with real humans. Then we are going to establish our entity relationship diagram, which is going to give us a lot of information. At the end, we saw that a tournament has many games, and the players can play many games as well, and there are some rules that are applied already in the design. We have some design principles as well, but don't be completely dogmatic about the principles. Sometimes you can change them. You can choose your suitable data type for everything, and if you don't have it, you can create your own data type and be bold about it. And then know that Postgres gives you a lot of guarantees and flexibility, and you can use it for many, many beautiful things and help to save some code from the application and to put it in your database design. And with that, I thank you very much, and follow me for colors on the slides for your next presentation. Thank you.
Thanks a lot. There's maybe time for 1 question. Because it's a short slot, okay.
Oh, yeah. So credits for Svetlana. Yeah, so Dirk is saying, can you give credit to Svetlana? Svetlana was the developer working on the front end of this application that we use for the chess tournament. Last year, when we have the meeting about designing the database, she was also part of this discussion, and it's the same software that we are going to be using for tracking the games that we are going to play this week. If you want to be part of the game, find us in the hacker room, or in the coffee break on the lunch, join us in the Telegram group. We are going to put some information in the social part of the Telegram. And if you don't know chess, it doesn't matter. We are going to teach you. If you want to win a chess game, play with me, because I'm a terrible player. If you want to learn, you can learn from Dirk. Thank you very much.
And,
So, thank you.
and if you want to ask question, join chess tournament.
Ah, yes, I'm going to be here until Friday evening.
Thank you.
Cheers.